Everyone, in this video we're going to solve a linear programming problem. What's going on here is there's a manufacturer makes two types of bikes, Model A and Model B. Takes 5 hours to assemble Model A bike, takes 4 hours to assemble Model B bike. Likewise, it takes 2 hours to paint a Model A and it takes 3 hours to paint a Model B bike. Now, there are only 200 hours available per week for assembling the bike, and there are only 108 hours available for painting the bike. Now let's talk about profit. All right, this company profits $25 per Model A sold and $15 per Model B sold. In this entire problem, let's just call the variable X the number of Model A bikes, and let's call the variable Y the number of Model B bikes. All right? And we're going to make an inequality out of this. It's going to be pretty simple. If X is the number of Model A bikes, then 5 hours per X plus 4 hours per Y must be less than or equal to 200 hours. And 2 hours per X plus 3 hours per Y must be less than or equal to that 108 hours. And our entire goal to this problem is to determine how many bikes should we make? How many bikes should that manufacturer make in order to maximize profit? So we'll come up with some profit values here in the end, and we'll look to see which is the highest profit value. That'll be our selection. But before we do that, we gotta sketch the system of inequalities here. All right, we have a system of inequalities. In fact, X and Y, you can't have negative bikes. So over here, X and Y, X must be greater than or equal to 0, and Y must be greater than or equal to 0, so that limits us to the first quadrant. But we do have some linear inequalities here, so let's graph these. If these are equal signs, let's graph those lines. We'll use the intercept method. Alright, let's get a point. If X is 0, I'll hide this, 5 times 0 is 0, 4Y equals 200, Y would equal 50. Let's get one more point. What if Y was 0? If Y was 0, 5 times X equals 200 and X would equal 40. So we got 2 points, and I can graph that line. If this was an equal sign, and at 0 it's 50, and 40, 0 would be right here. I'll do the same thing with this line. I'll use a blue marker for this. If this was an equal sign, let's graph that line. If X is 0, I got 2 times 0 is 0. 3Y would equal 108, and 108 divided 3 is 36. We need one more point. What if Y was 0? And if Y is 0, 2 times X equals 108, X equals 54. All right. So I'll plot that. Let's see, 54 comma 0, that's way over here. All right, and 0, 36, that'd be right about there, in between 30 and 40. All right, so let me graph this line. All right, there's that straight line. Now, we need to solve this system of inequalities. Which points will be shaded in this picture? Well, we've got to shade all points. If we solve for Y here, this would still be a less than or equal sign. If we isolated Y here, this would still be a less than equal sign. So we need to shade, in this picture, the region that's underneath this line and underneath this line in quadrant 1, which would give us all these points here. Yeah, all these points inside here will be underneath that blue line and underneath that black line, all in quadrant 1. We have now solved this system of inequalities. Now, any point in that red region, all right, satisfies the system of inequalities. But we're only going to look at the corners of the shaded region, the vertices. This point right here, which was this guy. This point right here, which is 0, 0. Let me get that in the list. 0, 0, 0, 36. All right, how many more vertices are there? There's 2 more. There's one right here. That's the 40 comma 0. And lastly, this point, I better put a question mark here. We haven't found that point yet. The point where those two lines intersect. All right, so I'll leave this blank for now. But what about the 0, 50 and the 54, 0? No, they're not solutions. All right, those points are not corners of that shaded region. So we can't use those. This point does not satisfy that system. Neither does this one. So we can't use those over here. We can only use points, right? They're inside that shaded region. But the corners, the vertices of that shaded region, all right? Those are the only ones we need to check to determine which one will maximize the profit for this problem. Now, lastly, let's get that point right there. All right, where do two lines intersect? We can do the substitution method, or we can use that elimination method. I'm going to use the elimination method. I'm going to make these two equal signs, and we're going to solve this. You got 5x plus 4y equals 200, and we got this 2x plus 3y equals 108. And what I'm going to do, everyone, to solve this little system here of equations by the elimination method, I see a 5 and a 2. Okay, well if I multiply a -2 here, that'll become -10. If I multiply a 5 here, that'll become 10. And I can add down and eliminate. So I'm going to do that. I'm going to multiply a -2 to this entire equation. And I'll multiply a 5 to that entire equation. Let's see what we get. I get -10x minus 8y equals -400. And if I multiply a 5 to that second equation, I get 10x plus 15y equals 540. Now I'm going to add down. Elimination method. -10 plus 10, bye-bye, 0. -8 plus 15, I get 7y. And -400 plus 540 is 140. So I have 7y equals 140. And y equals 20. Aha! Y equals 20. Now, if y equals 20, how do I get x? I can use any one of these to figure out x just by substituting this. How about I just put this 20 back right there for y, and I can solve for x without that 5 there. 2x plus 3 times 20 equals 108. 2x equals 60. I'll subtract the 60 from the 108. 2x equals 48. Divide the 2 on both sides, and x equals 24. That's this point. Let me take that question mark off. I found this point now. It's the point 24, 20. All right? That's the fourth corner of that shaded region, the fourth vertex. Now, or fourth vertex, excuse me. So now I'm going to put this in here, 24. This is 20. And that's the easy part. Let's just see which one of these 4 points maximizes profit. 25 times 0 plus 15 times 0, that would be $0. Yeah, we're not making 0 of each bike. 25 times 0 plus 36 times 15, that gives us $540. 25 times 40 plus 15 times 0, that gives us $1,000. And 25 times 24 plus 15 times 20 gives us $900. Which one's the highest? Right there. So, and here's our answer. Right there, there's our answer. We found it. What we're saying is, to maximize profit for this problem, you need to make 40 Model A's and don't make any Model B's. Make 40 Model A bikes and you'll get a maximum profit of $1,000. Okay? So make 40 Model A bikes, make 0 Model B bikes, and you'll get a maximum profit of $1,000. That's the best. Yeah, these all satisfy the system. Also, any point in this red region satisfies it, but this will give you the most profit. This will give you the most profit. All right? A lot of times when you work problems like this, it's funny because this point's sitting right here, many times can be the solution to the problem. But it's not always the solution to the problem. Because you got such a high X and such a high Y. As you can see, this one was higher than this by $100. So, that's it. And you can always make a concluding statement to this problem, all right? Explaining your answer. Make 40 Model A bikes, make 0 Model B bikes to maximize profit, giving you a profit of $1,000. And that's it.